Hello, and welcome back to Homework Help for Math 2. Today we're going to be looking at Chapter 6, Trigonometry, Lesson 3, Inverse Trigonometry. So the directions here say, find the measure of the missing angle to the nearest degree. Now, I'll go ahead and point something out here. First of all, I've numbered these problems going from left to right and then down. So I have 1, then 2 on the right, then 3 and 4. If you did these problems in a different order, then obviously that's a different number system. Also, I've gone ahead and I've labeled all of these triangles as ABC, just because I don't like solving for question mark. Like question mark's kind of like a weird symbol to like put into an equation, essentially, which is what we're going to do. So I just labeled them all as ABC, and we'll just solve for whatever letter is at the question mark. So, number 1. Like I said, the directions say find the measure of the indicated angle to the nearest degree, and my question mark for number 1 is at angle A. So I'm looking for the measure of angle A. I know that this is a right triangle, and I also know 2 of my sides. And so in that situation, when you have a right triangle and you know two sides, you can use trig and ultimately inverse trig to solve for your angle. So if I'm solving for angle A, I want to label my triangle with opposite, adjacent, and hypotenuse. And I want to start with the hypotenuse. So the 20 is across from the right angle. That means it's my hypotenuse. My opposite is the leg that has nothing on it, in this case. And my adjacent is the leg that has a 13. And what I'm looking for is I'm looking for which trig function, sine, cosine, or tangent, involves the 2 numbers that I'm given in this case, which are hypotenuse and adjacent. As a reminder, if you are struggling to remember the definitions for sine, cosine, and tangent in a right triangle, we have this kind of handy thing that, for whatever reason, helps people to remember our definitions. The definition for sine is opposite over hypotenuse. The definition for cosine is adjacent over hypotenuse. And the definition for tangent is opposite over adjacent. So whether you had to look up the definitions or whether you remembered them, the point here is that the trig function that we want to use is cosine. And we're going to use cosine because we're given the adjacent, we're given the hypotenuse. We don't know opposite, but cosine is the one trig function that doesn't involve opposite. So let's use cosine. So my equation, my initial equation, is that the cosine of my angle, which is A, is adjacent over hypotenuse. That's just the definition of cosine in a right triangle. Now what I want to do is I want to get A by itself, just like I do whenever I'm solving a linear equation or a quadratic equation. I want to get my unknown value by itself. The only thing preventing A from being by itself right now is the cosine function. So I want to get rid of it, and I get rid of it by using its inverse. Well, the inverse of cosine doesn't really have a fancy name. It's just the inverse of cosine, or cosine inverse. So I do that to both sides of my equation. And when I apply the inverse function to the inverse cosine function to the cosine function, on the left, they are inverses by definition, so they go away, and so A is by itself. Right? Cosine inverse and cosine are inverse operations, so they go away, and so I'm left with just A. Now, whatever I do to the left-hand side, I have to also do to the right-hand side. So because I took my inverse cosine of the left, I have to also take it on the right. Just like if I subtract 3 on the left, I have to subtract 3 on the right. If I multiply the left by 10, I have to multiply the right by 10. So there's my answer, right? So A is the measure of angle A, which is what we're looking for, is the inverse cosine of 13 over 20. Now, we want to round this to the nearest degree. So what that means is we're going to get out a calculator that has trig functionality in it, and our trusty TI-84 Plus does have that. We need to, because we're dealing with degrees, we again need to make sure that our calculator is in degree mode. If you have previously set your calculator in degree mode, and if you haven't modified that, or if you haven't reset the calculator, it should still be in degree mode, right? So when you turn it off and turn it back on, it's still in the same mode as whatever it was that it was in previously. For me, I deliberately reset my calculator, and so for me, my calculator is currently in radian mode. I have to go down and over to degree mode, and then I press second mode to quit. It's not a bad idea to just double check that your calculator is in degree mode, because otherwise you're going to get some kind of nonsensical answers because your answers are going to actually be in radians and they're just not going to make sense. So what I want here is I want the inverse, cosine inverse. Notice it's in blue above the cosine button. So I want cosine inverse of 13 over 20. And we're rounding to the nearest degree. And so if we're rounding to the nearest degree, our answer here is 49 degrees. So the measure of angle A is approximately 49 degrees. That's my answer for number 1. Number 2, I'm going to do this one a little bit quicker. So for number 2, again, we want to label our triangle relative to the missing angle. So here, 24 is my hypotenuse because it's across from the right angle. And relative to angle B, in this case, which is where the question mark is, 12 is opposite, and my blank side is adjacent. I want to use the trig function that connects the two things that we are told, which is opposite and hypotenuse. And the trig function that deals with both opposite and hypotenuse is sine. So sine of my angle, which is B, is opposite, which is 12, over hypotenuse, which is 24. That this does reduce to 1/2, and if you want to reduce it, feel free. But because we're just going to type this into the calculator, it's not really necessary. But if you did notice that this reduces to 1/2, then good job. Again, I want to get B by itself, and in order to get B by itself, I take the inverse of sine on both sides. On the left-hand side, my inverse of sine and sine cancel, and I'm left with just B. And then on the right-hand side, I have the inverse sine of 12 over 24. And so, assuming that we have not taken pre-calc yet, we're going to go to our calculator. And when I do sine inverse of 12 over 24, which again does simplify to 1/2, we actually notice that for this problem, we get exactly 30. And so that's my answer. And so going back, flipping back, right there. Oh, wait, hold on. Right there. Okay. So it turns out that for this one, our answer is the measure of angle B is exactly 30 degrees. And when you take pre-calc, I think, maybe in Math 3, but definitely in pre-calc, you'll sort of see why it's exactly 30 degrees for that triangle. But for now, the calculator said so. So we'll just accept that for now. Number 3. Again, we're going to label our triangle relative to the missing angle. My hypotenuse, as always, is across from the right angle. In this case, it's blank. My opposite is across from my question mark, which is angle A, and 38 is the leg that is adjacent. I want to use the trig function that connects the two numbers that I am given. In this case, I'm given opposite and adjacent, and the trig function that deals with both of those is tangent. So tangent of angle A is equal to opposite, which is 27, over 38, which is adjacent. I want to get A by itself, so I undo tangent, and I undo tangent by doing tangent inverse, or the inverse of tangent. On the left, they cancel, and I'm left with A equals. On the right, it's the tangent inverse of 27 over 38. I don't know what that is, so let's figure it out. 27 over 38, tangent. So I want second tan, 27 over 38. That fraction does not reduce. And rounding the nearest degree, I end up getting 35. So the measure of angle A is approximately 35. Let me write that a little bit neater. Is approximately 35 degrees. Okay. And that's number 3. Number 4. For number 4, you might get a little confused by number 4, but if you're confused about number 4, I just want to point out that number 4 is actually easier than 1, 2, and 3. Because with 1, 2, and 3, I mean, first of all, with number 4, you're just given, like, quote, extra information, right? Like, for 1, 2, and 3, we were given 2 sides. Well, now for number 4, the only thing different about number 4 is that we're given 3 sides. You know, if you understood how to do 1, 2, and 3, you got confused by 4, just first of all, just recognize that, like, you could treat number 4 like we treated 1, 2, and 3 and just sort of focus on 2 of the sides and then just solve it, because we're literally just given extra information. So 4 really shouldn't be more difficult, because in a pinch, you could just treat it like 1, 2, and 3 and just solve it the way that you treated 1, 2, and 3. With 4, we are not locked into using sine, cosine, or tangent. We can use any of them that we want. So let's go ahead and just label our triangle for number 4. 70 is the hypotenuse. It is across from the right angle. We also know it's the longest side. 42 is opposite, my question mark, which is in this case is angle A. And 56 is adjacent. And so what I want to do here is I want to use a trig function where I know both things, right? Opposite and adjacent, or opposite and hypotenuse, or adjacent hypotenuse. And because I know all 3 sides, I can pick any of them that I want. And we've already done a sine, a cosine, and a tangent. So I'll just do the first one that we did, which was cosine. So if I'm going to use cosine, we're going to use adjacent, and we're going to use hypotenuse. So I'm just picking cosine randomly, I guess you could say. If you used sine or tangent, then that's fine as long as you use the right numbers. That's perfectly fine. I'm going to use cosine. So cosine is adjacent over hypotenuse. So for me, because I'm using cosine, I have to use the 56 and the 70, right? Opposite does not appear in the definition for cosine, so that's why I'm not using the 42. If you used sine to solve this problem, then you should use the 42 and the 70. If you use tangent, then you should use the 42 and the 56. Again, I want to get A by itself. So in order to do that, we have to undo cosine. On the left, we get A equals. And on the right, I get the inverse cosine of 56 over 70. And so the measure of angle A is approximately the cosine inverse of 56 over 70. So inverse cosine, 56 over 70, close parentheses. Again, you could reduce that fraction a little bit. It reduces to, what, 28 over 35? And that might be all it reduces to. But it doesn't really matter because we're just going to type it into the calculator anyway, and we end up getting, rounding to the nearest degree, this is 37 degrees. So question 4, this is approximately 37 degrees. That's my answer. Number 5. Number 5 is very similar to number 4. Very similar. You have a surplus of information here. And so you can use sine, cosine, or tangent. It doesn't matter as long as you use the correct numbers. And yeah, so I guess I'll use tangent, because why not? So if I'm using tangent, sorry, I have to label my triangle. So 85 is the hypotenuse. It's across from the right angle. It's also the longest side. 68 is the leg that's opposite the question mark, and 51 is the leg adjacent to it. Again, I'm just using tangent because I feel like it. So tangent of A is, the definition for tangent in a right triangle is opposite, which is 68, and adjacent is 51. Notice that I have a fraction that's larger than 1, which if you're using sine or cosine, that's a problem, but tangent can be over 1. Right? So it just turns out that because we're using the tangent function, it's not a problem that our numerator is larger than our denominator. But if we were using sine or cosine and we had a fraction that's larger than 1, that's a problem. Because sine and cosine will never, ever go above 1. So just something to be aware of. I want to get a by itself, so tangent inverse, or inverse of tangent. I end up getting a equals the inverse tangent of 68 over 51. And so the measure of angle A is approximately, whatever that turns out to be. So 68 over 51. Inverse tangent, 68 over 5(1), close parentheses. Rounding to the nearest degree, that is 53 degrees. So approximately 53 degrees. And I don't like that box. Do it one more time. There we go. All right, and question 6. Question 6 is similar to 1, 2, and 3, and that we're only given 2 sides. Even though we could use the Pythagorean theorem to solve for the third side, it doesn't really make any sense to do so because it's perfectly fine just to use the 40 and the 42. Again, I'm going to label this triangle according to angle A. So 42 is the hypotenuse because it's across the right angle. 40 is the leg that's opposite my given, or the angle that I care about, and adjacent, which is blank, is the leg that's next to my missing angle. Unless I want to solve for adjacent, I have to use opposite and hypotenuse, and the trig function that deals with opposite and hypotenuse is sine. So if you don't want to make a lot of extra work I'm going to move that down a little bit. If you don't want to make a lot of extra work for yourself, I recommend that you use sine for this question. And the sine of my angle, which I've arbitrarily labeled as A, is 40 over 42. You could reduce that to 20 over 21, but I'm not going to. We'll get our unknown by itself, use the inverse of sine. So A equals inverse sine of 40 over 42. And so the measure of angle A is approximately something. Sine inverse 40 over 42, which is 20 over 21. Rounding to the nearest degree, we get 72 degrees. So this is approximately 72 degrees. And assuming that my triangle is drawn to scale, which it kind of is, it looks like, that certainly looks like a 72-degree angle. It's acute, but it's kind of a large acute angle. And so that's my answer for number 6. Question 7, which is from the original book. Solve each right triangle. Now, in case you don't know what it means to solve a triangle, it tells you in the second sentence. What that means when it says solve a triangle, it means give any missing sides and missing angles. So even if you didn't know what it meant to solve a triangle, well, the second sentence tells you what the first sentence means to do. So a triangle has 3 sides and 3 angles, so that's 6 things, and of the 6 things, anything that's missing, provide it. Well, taking a look at this triangle, of the 3 sides, we know 2 of them. We know this is side C, because it's across angle C, and we know side B, because across angle B, but we're missing side A. So that's one of the things that we're missing. And then among the angles, we're given angle C, which is 90, but we're missing angle A, which is right here, and we're missing angle B, which is right there. So we're missing 1 side and 2 angles. And as soon as we give all 3 of those missing things, we are done this problem. And you could really do them in kind of any order. You could solve for side A, you could solve for angle A, you could solve for angle B first. So it doesn't really matter which one you do first. I'm going to solve for my missing side first. And that's just like personal preference. If you solve for the angles first, that's perfectly fine. You don't need side A to get angle A or angle B. But I'm going to solve for my missing side. When we have a right triangle and we are given two sides and we are solving for the third side, the thing that we want to use is the Pythagorean theorem. And the Pythagorean theorem says, as always, that the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse, commonly written as a squared plus b squared equals c squared. And this is true only if C is your hypotenuse, which in this case it is. C is my hypotenuse, so I don't have to mess around with the A, the B, and the C here. A is the thing that we're missing, so I'll just leave it as A. B is my leg that we're told is 17, so 17 squared. And C is my hypotenuse, which is 18. This next step is not strictly necessary, but I find it helpful to simply evaluate the squares. So A squared plus 17 squared is 289. And 18 squared is 324. I'm trying to get A by itself, so the first thing I want to do is I want to get rid of that 289 and get rid of that 289. Cancels. So A squared equals 324 minus 289 is 35. And so therefore, A equals the square root of 35. Now, it doesn't say what to round to. It doesn't say give an exact answer. So the directions are a little unclear as to what format this should be in. The square root of 35 does not reduce, so you can't simplify it. So the square root of 35 is your exact answer. And if you want to give an approximate answer, say rounding to the nearest tenth, which is sort of like my default thing that I do, we end up getting 5.9. So because the directions were a little bit unclear as to how to express your answer, either of those would be fine. So A is either the square root of 35 or approximately 5.9. That's my missing side. Now to get my missing angle, I guess we'll just go in alphabetical order here. So I'll get angle A. In order to get angle A, we're going to use inverse trig. And so let's focus on angle A here. So if I'm focusing on angle A, then 18 is my hypotenuse. Side A, which I just solved for, is opposite. And 17 is adjacent. And that's because I just sort of randomly picked angle A. If you wanted to solve for angle B first, that's fine, but your opposite and adjacent would be flipped from my picture. So the way that I've labeled my right triangle here, this is specifically in regards to angle A. So I'm going to solve for angle A. Now, I did solve for my missing side here, which means I could use any trig function I want. I could use sine, cosine, or tangent. However, it's probably a good practice, just on the off chance that I made a mistake solving for my side, just to be extra careful here, let's use the sides that we were originally given. Because again, just on the off chance that our side was wrong, because none of us are perfect. Maybe I made a mistake. I didn't. That is the correct answer. But maybe I screwed it up. And so let's go ahead and use the sides that are given. Again, just on the off chance that we made a mistake when we were solving for our side. So if we use the given sides, we labeled those as hypotenuse and adjacent, and the trig function that deals with both hypotenuse and adjacent is cosine. So cosine of A is adjacent, which is 17, over hypotenuse, which is 18. I want to get A by itself. So the thing preventing A from being by itself is cosine. So in order to undo cosine, we use cosine inverse. So cosine inverse and cosine cancel, so I'm left with A equals. And then on the right-hand side, I have the inverse of cosine 17 over 18. And I don't know what that is, so I'm going to go to my calculator. And I'm going to say cosine inverse of 17 over 18. And I guess for my side length, I rounded to the nearest tenth. So for this one, I will also round to the nearest tenth, and this is 19.2. So this is approximately 19.2 degrees. So if you want an exact answer, your exact answer is this guy, right? There's no other way to write it as an exact answer other than to keep the trig inverse function in there. So you kind of have to round this one because otherwise you're left with an answer that's technically correct but isn't really super useful. So the 19.2, I would say, is how we should express our answer here. We kind of have to round this one because it's not a nice round number. So the measure of angle A is approximately 19.2. Now, to get the measure of angle B, I could use trig again, or I could just recognize that the sum of the angles of a triangle is 180. And so because angle C is 90, and because I've solved for angle A, well, I can pretty easily, without even using trig, I can solve for B simply using the fact that all three angles sum to 180. Now, not only do all three angles sum to 180, but because one of my angles is itself 90, it means that my other two angles, angle A and angle B, those two angles must also sum to 90, because together it means that all three angles will sum to 180. So in a right triangle, your acute angles are what are called complementary. They sum to 90 degrees. So because the measure of angle A is 19.2, the measure of angle B, well, here, I'll write the whole thing out. The measure of angle A plus the measure of angle B, they must sum to 90 degrees. Because together with C, which is itself 90, all three angles sum to 180. So again, my acute angles in a right triangle are always sum to 90 degrees, and that means that they're called complementary. I know the measure of angle A is 19.2. Plus the measure of angle B has to get me to 90. So if I subtract 19.2 from both sides, I get that the measure of angle B is approximately, I could do this in my head, but I don't want to screw it up, 70.8. And so I have provided the missing side. I provided both missing angles. This is 70.2. So I have now solved this triangle. All three sides and all three angles have been identified, and that is it for question 7.